Right. So the formula for specific heat capacity is E is equal to mc delta theta. And Aliyah, the specific heat capacity is how much heat energy in the basic temperature of 1 kilogram of a substance by 1 Kelvin. So it must be a kilogram of the substance. Right, and last class we looked at heat capacity. Right, so I can give you all some time to copy this down fast. So heat capacity is represented by a capital C. Specific heat capacity is given by a common C. So I give it only 3 minutes to copy this on. Everybody muted. Ooh, wait, Justin. Justin, you home?
Yeah,
Oh, you're real quiet today.
no, nah.
I see the sounds. The sound coming out real good.
Yeah, we halfway finished. We just had a it have a show coming up, I think August 18, 2020, so we barely got to carry.
Oh, okay, okay. I remember you asked me for some help with some simultaneous equations question, but never get a chance. Hmm.
Oh, nah, well, the questions we had, I get through the elimination and substitution method, but I like the part with the graph, that kind of confused me.
Okay. Anytime you have two lines, wherever the two lines just cut each other, that is the okay, so when you solve a simultaneous equation, you just find for x and you find for y.
Yeah,
And if you have a graph, I would just say you have two lines on the graph. If the two lines cut each other, the point at which they cut each other, that point, that's the x and y value. That's your point. Other than that, that's what you're talking about.
yeah.
Yes, so Aliyah, please let me know as soon as you have this copy down, because you are moving with speed today.
And the formula.
All right. Right. Justin, you have everything copied down there?
Now the differences.
All right. So the main difference is that heat capacity do have what in it. Justin, look at the units for specific, sorry, look at the units for heat capacity. You seen any kilograms?
No,
Nah, so heat capacity don't have kilograms in it. Specific heat capacity has kilograms in it.
Finish it.
Okay. Thanks for letting me know, Justin. Aliyah, are you done?
On the last word.
Okay. So, Justin, do you know what the specific heat capacity of water is?
Mm,
Starts with four. Anybody know what the specific heat capacity of water is?
Is it 42,000?
42,000? No, 4,200
100?
joules per kg Kelvin. Right. You have it down there?
Yeah.
Right. So the difference, they could ask this. So while specific heat capacity is used for materials and is a constant that only accounts per kg, heat capacity is used for bodies and is dependent on the mass of that body. So like we would use heat capacity for us, right? Nicholas, yeah, but you know about this experiment?
Um, yeah, we told me I see that before in my physics book.
This is the um this is testing for specific heat capacity using a calorimeter.
I remember seeing it, but we never really went into depth with it.
Oh, and this one over here is by the method of mixtures. Right, but we that is hardly count. This is count though. Specifically on heat counting. That's in love to count.
Mm,
Right? Before we move on, let me just do some questions with you all since most Ali wasn't here yesterday. So Aliyah, just remind me, what is the formula for specific heat capacity?
E is equal to MC delta theta.
Right. I want you all to copy these things down to the side. You only use this formula when there is a change in temperature, not a change in state. Change in temperature, not in state. Okay. Other thing is delta, like when you doing a calculation for this, the temperature could be in Kelvin or Celsius, but both had to be in Kelvin or Celsius, right? Doesn't matter if it is degrees Celsius, Kelvin, the specific heat capacity of water is 4,200 joules per kg Kelvin, right? When you're using this formula, you have to make sure everything is in the SI units. Justin, what is the SI unit for sorry, not for for temperature. What is the SI unit for mass?
Kilogram.
Kilograms. So if you see anything that is not kilogram, you have to convert it. Right. So I want you all to copy down all these guidelines, and that should help. So, Aliyah, if in a question you see they say that you see that ice turn to liquid, will you use E is equal to MC delta theta? Ice turn to liquid. Aliyah?
Yeah.
Ready first thing.
But aren't you changing the temperature because it melts?
It melting, right? It melting.
Yeah.
Let me explain something. If you have a block of ice and you want to turn it into water that is 50 degrees Celsius, right? Let me explain what happened. Before you could heat up, before you could even get water, and the ice had to turn to water, and the ice will turn to water,
Yeah.
and it's only when the water, and it's only when the ice turns to water, it's only then you can heat it up. You understand?
Yeah.
Because if you put a flame over ice, would it remain the same but change temperature, or it turn to liquid?
Wait, you can repeat? Sorry.
If you take a flame, right, and you put it over ice, will the ice will the ice get hot, or will it turn to liquid and then
It will
get
turn to liquid. It will turn to liquid and then get hot.
right? So the first thing that has to happen is a change in state,
Okay.
and we use a different formula for that. It's only when it's water, it's only when it's between water and water, you can use E is equal to MC delta theta. It must be the same state, right? If you're seeing a change in state, chances are you're not going to use this formula. So Justin, you there?
Yeah.
If you drink water, water is a liquid solid gas with water,
A liquid.
right? And let me just say it's a hot day. You drink water. That water we're gonna happen to that water. You drink. And it's a real hot day. You need sun.
One boil.
Yeah, the water, right?
Another one boil by one. Yeah.
You say drink the water, it's in your body, and it's real hot. And you're gonna have a sweat.
Yeah.
And then that sweat go evaporate off your skin.
Yeah.
So the water is a liquid, and a liquid turn into what?
Gas.
Gas. So there's a change in state, right?
Yeah.
Yeah. So would I use E is equal to MC delta theta there?
No.
Nah, because he's only use a formula when there is a change in temperature. And what I mean is, so you see how you're going from liquid to gas? You can't use that formula because this formula does only work when it's the same state, like liquid, liquid, gas, gas, solid, solid. Yeah. All right. So when you all have everything copied down, let me know. Alia, you have that copy down?
Yeah,
Could I tell me something?
sorry. I'm
So,
now finished. Well, like 2 minutes now.
all right. So let me get some questions loaded. And we would have done these questions yesterday, but I'm just gonna reiterate it for anybody who missed yesterday. Right. So who wants to help me with the first question? Anybody? Everybody real quiet, boy. I promise it's real easy. Justin.
Yeah.
Justin, you will help me with it.
I will try.
All right. So I want you to read question 7.
How much energy is required to heat 3 kg of water from 30 degrees Celsius to its boiling point?
All right. So is there a change in state over here?
Yeah.
No. Did they say it turned to steam?
Oh, no, no.
They just say we heating it up to the boiling point. What temperature is the boiling point? What is the boiling point of water?
Um,
100 degrees Celsius.
Yes. Yeah. Justin, you're supposed to know that one day, right? 100
yeah.
degrees Celsius. That one a little inexcusable, right? Because water does turn to steam at 100. What temperature does sorry, what temperature does water freeze? Water freezes
0
at,
degrees.
right. So there is no change in state, so I can use E is equal to MC delta theta. So let me calculate the energy. So what is the mass? What is the mass of the water?
3 kg.
Right? So the mass is 3 kg. What is the specific heat capacity of water?
Um, it 4,200
40,
joules per kg Kelvin.
right? So I'll put the 4200 here. And the change in temperature. To figure out the change in temperature, That's the temperature between 100 and 30. So what's the difference? Or was it change in temperature? If you want to go from 30 to 100,
70 degrees.
right. So I'm gonna put 100 minus 30, right? In the next line, I will put 3 by 4200 by 70, and you're gonna plug that into your calculator. And the answer will be in what units?
Joules per kg.
What's this? Tell me, Justin, what is this? What does the E stand for?
Energy.
Energy. And what's the unit for energy?
Joules.
Joules. So it wouldn't be
Ah,
per kg, it would be joules. Because here's right. They're asking you how much energy is required. And that's why we use this formula, because this will tell us how much energy is equal, right? So tell me what the energy will be equal to.
um, 882,000 joules.
882,000 joules.
Yeah.
Was that hard?
Nope.
That was lightweight. Nicholas, not easy, right?
That was real easy.
Yeah. Alia, what about you?
Yeah,
Right?
I
So
should do that one.
shut up. Right now I'm gonna give already the slightly difficult question to do, slightly more difficult question to do. Right? Let let me get back the hacks for you all. And you all copy down the little hacks or tips in our book for the formula. That's why I just don't make all the copy down. Like with a bunch of points.
Yeah,
All right. Well, give question eight a try then. Do you all know how to convert degrees to Kelvin? You all know how to convert Celsius to Kelvin? Aliyah, someone. Finally, real rusty, real rusty. How do we convert Celsius to Kelvin?
you have to add 273.
Yes. Right. So give question eight a try. Give it only 5 minutes. So guys, look at the main points. Look at the advice I gave all just now when you're using E is equal to MC delta theta. Please pay attention to it. By the way, let me just remove something from this question. Right? Don't worry about this part. Just find how much energy you need to heat the water to boiling point. So Justin, what was the first thing you do in this question?
Highlight the main points and then um you look for the mass at the water and then the thing.
So follow the points from again. What was the main points?
Main points was if I don't know how much energy is required, the mass of the water is 2500 grams. Um and it was initially at 300 Kelvin and you had to find it at its boiling point.
Okay. And what was the points I made you all copy down? So E is equal to MC delta theta.
Change in temperature, not in state. Theta does not matter if is in degrees Celsius or Kelvin. C of water is 4200 joules per kg Kelvin. That's a unit. Mass is kg, but mass is kg. Delta
Right.
theta just means change in temperature.
Okay. So in this question, we see net mass is 2500 grams. Hmm. Hmm. And they give it temperature in Kelvin, which is fine. That just means you had to do something extra for the boiling point. So see if you can figure it out. You know how to convert Celsius to Kelvin?
No.
Aliyah, tell Justin how to convert
Oh wait, no, and that's it. We had to add it
Add
to something.
273. Yeah.
Yes.
that is it. Hey Aliyah, you have all the new Shandy flavors?
We have new flavors.
Yeah, tamarind and pina colada.
Oh, I don't like tamarind.
Well, you try it.
I don't mind trying the pina colada. I love a pina colada.
But tamarind, boy, that real weird. That real weird.
Yeah.
Right. Nicholas, you got through with this question?
Almost done.
Kristen, let me know if you getting through with this question. Justin, you know what to do for this question?
trying something.
So what was the first thing you did in this question? What was the first thing you think you should do?
Um, write down the mass
But
prime contact.
right? But according to the key points, where your mass supposed to be in,
kg.
right?
Oh,
So that's the first thing you have to do,
right.
convert the kilograms. And what's the boiling point of water?
100 degrees Celsius.
But as in degrees Celsius. And in this question, they give you the initial temperature and what?
Kelvin.
Right. So I wouldn't spoil it here. Figure out the rest. Okay. Nicholas, I see a mistake.
It is.
You need delta theta part. That's what I see in a mistake.
Alright.
Let me explain something. It doesn't matter if it's Celsius or Kelvin, right? But the two units must be the same. So in the first question, I decided to work with Celsius. So I had 30 and I had 100. Both was in Celsius. In question 8, they gave us the initial in 300 Kelvin, right? So we had to work with Kelvin.
I had to understand.
Aliyah, are you getting through?
I think so.
Son, my picture, are you working?
Really?
Yeah, son, my picture, are you working?
Okay.
I need to try doing something. That is all you have?
Yeah, I kind of looking at my brain because I'm trying to figure out what to do.
Hold on, write down the formula. Justin and Aliyah. Guys, I want you to write down the formula. E is equal to mc delta theta. So Justin, you're converting mass to kilograms.
Yeah,
So 2,500 grams is how much kilograms?
2.5.
Right, so you have the mass, right? And we know what C is. What is C?
4200.
4,200. We know what that is. So we have M, we have C. Now we need to find for delta theta, which is the change in temperature. Ali, are you with me?
Yeah.
So we just need to find delta theta. So what was the initial temperature, guys?
300K.
Right? And we want to carry that, we want to raise our temperature to the boiling point. What is the boiling point?
100
100
degrees.
degrees Celsius.
But the problem
So
is, this is in Kelvin and this is in Celsius.
you have to convert the boiling point to Kelvin. So
Yeah.
that'll be 373 minus the 300.
Yes.
Okay.
Justin, you want to explain that one more time?
Nah. So the boiling point is 100 and you add in 273 to get the 373.
Right. Because
to change it to Kelvin.
when you're doing this calculation, whatever unit you're using for temperature, it had to be the same throughout. In the first question, everything was in Celsius. You see that, right?
Yeah.
In the second question, everything was in Kelvin. Mhm.
Okay.
Yeah, Nicholas, that's correct. That's correct.
Alright.
Yes, Aliyah, that is correct. Right? I just waiting on pictures from Kirsten and Justin. Right? Right? In the meantime, I want those who got it correct. I want you all to do question 11E. Do question 11E. Right, Justin, one thing. Yeah. Inside the bracket, you need to put 373 minus 300. But yes, that's the correct answer I got there. So I want everybody now to try question 11. Justin, I see you change your phone.
Yeah, change my phone. The other one, I don't, the screen started bug out and things, so I said I'm gonna change it before I lost everything.
Oh, okay, okay. I do that too.
So try iPhone.
Oh God. Mm, lose one, we lose
That's
one.
what we're talking about.
Don't worry, I still have a Samsung.
I hate
Oh
Samsung. Don't come with Samsung. Samsung.
my
Nah,
gosh.
but my main one right now is iPhone. I had the 13.
Oh,
Yeah.
not me an iPhone, yes. I uh I might eventually get one for business, or for personal use. I would never buy an iPhone.
I was going back to Samsung like a S phone or something, like the S23 or the S24, but I say,
But
for the storage, just gonna just try the iPhone.
the S23 Ultra. I have the S23 Ultra and I replace it. I bought another phone. The S23 Ultra, it's it's okay. But for the price, I don't think it's worth it. I really don't think it's worth it. Like, I really don't think so. Samsung in general, just don't like Samsung. Anybody here into phones and thing? I don't know about OnePlus, Xiaomi. Anybody? Nicholas, you know about phones?
I know about every kind of phone in existence.
You know about the OnePlus 12?
Nah.
You know about the Xiaomi 14 Ultra?
Yeah.
You know about the Find X7 Ultra?
Now my main about every phone.
Well, it just you know about every phone. Oh.
Ah, nah, 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 nah. It's always have a bigger fish. It's always have a bigger fish.
So Justin, um, how much storage your iPhone have?
Mine, I have 256.
Okay, that's a good amount of storage. I will ask you.
Yeah. I was going to get the option to upgrade it to terabyte, but I say, me has so much thing to think about with terabytes. So I say 256 good. So wherever I need, I just delete and have.
Yeah, 256 will be enough. Oh, Kiara said to say hi. She says hi to everybody. She just messaged. Um,
Why is she not in class?
she walking. Like literally, she walking. Right, so question 11. I want you to try question 11. Justin, you see speed on that thing?
Not moving her else.
Yeah. Tell you, Samsung and Apple isn't everything. That's
Nah.
so much on our phone makers.
These are what kind of phone is this?
That one plus 12.
Oh,
Real fast, boy. Wait. This thing,
and the
crazy.
camera clear in it too, though.
My camera real good.
I'm gonna zoom it up because I know the S23 I want with 100.
This are 120.
Oh, nah.
But wouldn't lie, the zoom. Okay, like if you want to zoom in, like if you want to take the phone and zoom in close to something like your hand or something, or so, like an insect, this better. I
Hmm.
didn't I didn't check the moon zoom on this, but the camera quality, it's pretty good. Just get the phone. Right? So I don't think I'll even need help for question 11. Aliyah, you think you're gonna need help?
No,
Okay, good.
Not real clear. But that,
And this thing charging 30 minutes. It's
hmm.
charging.
My father had the S23 and he said the take what was that? Oh, 120 something minutes where he want to charge.
Yeah, the S23 Ultra. I I get fed up how long it take to charge, honestly. For a phone that costs like $8,000, come on.
Yeah.
Charge faster now. What you doing? And this the battery life in this last 13 hours. 13
Um,
hours. I see Nicholas quick on the draw. Yeah, Nicholas, that's correct.
All right, I'll look in.
One thing though, where you get joules minus 1 kg minus 1 from? One we want to figure out heat energy. Remember, is E we find
Oh,
out.
oh yeah. That's my bad.
So where's the units for E?
It could be just joules alone.
Yeah, just joules.
think mine might be wrong.
Negativity, boy. Nah.
Yeah, most likely mine wrong.
Why you say that though?
I don't know. Try something.
Yeah, that correct though. That correct.
Well, I surprised myself.
Right? Aliyah. I waited, huh? I waited. Aliyah. Wonder why Aliyah there, boy. I
Yeah,
heard
no, like I write it.
the
I'm doing it.
boys kind of winning today.
Mhm.
That's a speed, boy. Oh, God.
Yeah, it's insane. My son, like the S23 Ultra is lag. Is like and animations it okay, yeah? But like if I had time to do that, you go see some drop frames. So like Samsung is like not this way.
Yeah, plenty Samsung phones I see currently move with so much speed as well.
Yeah. Check that video I sent you. You will see when I say the S23 Ultra really not as fast. And the thing about this phone I buy is like it's $4,700. The S23 Ultra is like 8,000 or so. You see the difference, right?
Yeah, see the difference. It very. If I try to do it on my phone, I show my phone blow.
Try it. What kind of phone you have?
I
Those
have
nice.
a E23
Oh, they cooked there, cooked.
like since a long time.
If you want a good budget phone, Infinix, Tecno, Xiaomi, Poco, Realme, and the good phones. Do do buy a Samsung phone. The only decent Samsung phones cost like a arm and a leg.
Yeah, exactly. I remember 2 years ago I buy this phone. I spent my whole budget on this phone alone.
How much you spend?
Um, I think it was I can't even remember, but all my money was gone.
Here what? If you're looking for a phone under $2,000 and you want a fast phone, just message me. I'll find a good phone for you.
Right, good.
$1,800 only a good phone. Not a good Samsung phone, but a good
Shut
option.
up. Shut up, see Samsung now.
Well, Samsung was good back in the day, but now I don't know what they're doing. Right? So Aliyah, still waiting, still waiting. Hmm. The boys winning by a marginal leap. Kind of crazy. Okay, Aliyah.
It was taking long to send.
Oh, yeah, that's correct, Aliyah. That's correct.
I was supposed to ask for going on the rivalry between Kavir and Alka.
Long time, I find you not talking to each other and saying, I don't know what's going on. I don't know.
Hmm.
We normal.
All right, you say so.
We are.
You saying that, but Justin is saying that.
Okay, so I guess we're not normal then.
No. But I doing my physics.
Okay. So, time
Okay.
to, time to learn the other part of the puzzle, specifically latent heat. So, guys, if you have ice and you want to heat up that ice to water at 100 degrees Celsius, before you could even heat up the water, and the ice had to turn to water, Justin, you know what I'm saying, right? If you put a lighter over a block of ice, and the ice go first turn into water, and then it's only after it turns into water you can heat up that.
Yeah,
So let me say that one more time. When you put a flame by ice, the ice is getting hot or the ice is melt. What does happen?
well,
It is melt, right? And it's turned to what?
liquid.
Liquid. And it's only after it turns to liquid, then it can heat up.
Yeah,
So Justin, when it turning from ice to liquid, you think that take energy?
I still liquid. Yeah,
Yeah.
no, yeah.
Let me ask that question. if it would take energy for you to change into what way? Hmm. He's already a good child.
Of course.
Let me trouble Aliyah. And it would take Aliyah real energy to to like beat Aliyah in physics.
Hmm. I don't answer now. That's somebody else.
I joke.
Wow. Okay.
It's like Aliyah was holding a gun to Justin head just now.
I trying to be nice.
He not gonna answer. So
Okay.
what? You can't be nice?
So, Aliyah, will it take plenty energy for you to become good in chemistry?
Yeah.
Yeah, so it's a change, right? So anytime you're changing, it requires energy. So anytime you're changing state, it takes energy. And we refer to it as latent heat of vaporization and latent heat of fusion. Let me explain. So if you're going from gas to liquid, Nicholas, and that's a change in state?
Nicholas, nine class.
Oop. Well, Aliyah, if you're going from gas to liquid and that's a change in state,
Yeah.
remind me, which form of matter has the strongest bonds? Which type of matter?
Solid.
Solid. After solid is
Liquid and then gas.
right. And what holds the atoms together? The
Molecular structure.
intermolecular bonds.
Bonds, yeah, not structure. My bad.
Justin, which one have the strongest intermolecular bonds?
I saw that.
What was that? That didn't sound like Aliyah. That did not sound like Aliyah.
Nah,
That, that
totally
it
not.
do.
Die my mind to hammer.
Right. So Justin, the intermolecular bonds is what keeping the atoms together. Right? As
Right.
so a solid, the atoms in a solid, they could move about.
Nope.
No, it can't really move about. How about a liquid
Yeah.
and a gas?
Yep.
Right. So when it changes state, the intermolecular bonds is changing. And to change the intermolecular bonds, that requires energy. So again, latent heat of vaporization and latent heat of fusion. Yeah. Right. So I want you all to copy down this. This is called, let me see if I could figure this out. Does this look like a cooling curve or a heating curve? Alia, Justin, does this look like a cooling curve or a heating curve?
That's a coolant curve.
Justin, you agree?
Yeah.
Why is it a cooling curve, Justin?
Because I'm gonna make a wild guess. You're going from gas to solid.
Right. And to go from gas to solid, you gotta cool it down, you know?
Yeah.
And another thing, look at the temperature. Your temperature going from higher to lower, right? So this is called a cooling curve. I want you all to copy this down, right? Graph showing cooling curve. To copy this down, it might take a little while. I'll copy it down. And we at the brink of finishing thermodynamics. We're on the brink.
So a cricket match after this start of start of November. So if you see me not answering much questions, that's why.
Oh, cricket match.
Yeah, but make sure and come to class.
Ooh, that's good that I come to class too. Very dedicated.
Yeah, can make cricket my whole life.
Exactly. Although he is a big cricket star and thing. Next CJ Bravo, you know.
Nah, me know what that.
I have a little problem.
What's the little problem?
I'm not finding my pen.
They're finding a pen.
No,
What?
I don't know where it's gone.
And you know the song, Sunita, go on. You know, my pen go on. Yeah.
Hey, so you know something I feel like I see earlier the other day, you know.
Wait,
Where? Oh my God, where?
I don't know if it's you or your brother, I see. But I see one
Where?
other.
Where?
Um,
oh, yes.
uh,
Yeah, right on the road. There's
yeah, and
right on
what's his name of that boss?
the
Home
stretch.
stretch.
Yeah, they over there.
Justin living
Well,
right beside Voodoo Trace. I mean,
right inside
Okay.
it,
yeah.
literally inside that trace, drive straight down. You have an next trace, drive in there, living ready.
Wait, the trace to go into home stretch, like the trace right there?
No, not they.
You
Oh
know
fuck!
Voodoo
Um,
Traces?
by
Yeah, we're here. Just live, yeah.
Yeah.
You're not living in any branch trace.
yeah,
Oh, okay. Which one are the branch trace?
two. Well, so you see where's that doctor place is called Rookner? Is Rook no, not Rookner.
I'm not sure.
Went to like a doctor place or a clinic, nobody.
And I know it have a dentist inside there. No, wait.
I
I
have
know
no.
where branch two is.
You know
No,
what
I know
Davy Roti Shop is?
Wait,
the beer shop.
Davy Roti Shop, yeah.
I think so. Yeah.
Inside that trace, it goes straight down. And when you're driving straight down, that one next trace, you turn inside that trace and right inside the element.
Okay.
Yeah.
but wait, Justin. Um, I know where you live in, and I don't know any of the landmarks you're talking about.
Really?
Yeah.
Huh?
All them landmarks you talk about just now have me lost. I yeah.
I kinda lost
Mm.
too.
Or you could just type up my father barber shop on maps and you could get the exact location.
Your father is a barber into?
Yeah.
Aliyah. Yeah.
Um,
No one knows, but I have a lot in common.
Type up VIP cuts by Jason and you'll get on maps. And you'll get the exact location.
Well, I know where you live in though.
Mm.
Wait, but you don't have the barber shop right there?
Yeah.
VIP cuts, barber shop.
Right? When you type it up, the house right here and the barber shop are like right in front. So everything right there.
Okay, okay. I see you have a roti shop, but I didn't know that.
I know the roti shop he's talking about. And that's
It
like the
had
food.
two. It had two, but one closed down, and the main one time inside, you know, it's Davy's Roti Shop. It kind
And
of
that's like one like right as soon as you're driving the trace.
no further down. It's a kind
Oh.
of brownish, yeah, kind of brownish color.
It have like a burgundy iron though. Like that's the color though.
Yeah, yeah,
Yeah, that's the same one I was talking about.
yeah.
Hmm. Right? So when you all copy down the coolant curves and mark it down. So yeah, you're copying on the curve, right?
What was that?
You're copying on the curve, right?
Yeah, I still kind of worrying about my pen.
Yeah, still looking for your pen.
Yeah, but I copy, I draw it. I'll draw it. Hold on.
You using different colors or anything?
No, I use my pencil.
Oh,
Yeah, not so. I'm kind of boring today.
um, today's our boring day.
Yeah,
I like
kind of.
everybody, and then you kind of low today. Yeah,
Yeah, today's just like a bummy day.
yeah, I ain't feeling the vibes. I'm not feeling
Yeah,
it.
I mean, and I lost my pen too, so I feeling to cry.
You need a good Jerry.
Yeah. I sent you a picture of my graph. Well, cool and cool.
Okay, you had to label everything, eh? So you had to put gas, you had to put LV being released, liquid, all that.
Yeah, I find my pen, so I'm going to do it now.
Nice. What? That real long key, Justin. Yeah.
Check.
Something I should,
My art skills not only pointed here.
something I should tell you, right? This LV, this supposed to be on the line. Yeah, supposed to be on the line. This LF supposed, well, it do be LF good. And LV, does anybody know what LV stands for?
No,
I'm gonna write that down to the side there for them. Nicholas in class.
no, he didn't join back.
Somebody go in the chat and call him out.
Justin, that your friend.
Right? So LV is latent heat of vaporization. LF is latent heat of fusion. right? And make sure and write A to D is the gas being cooled, B to C is condensation, C to D is the liquid being cooled, D to E is a freezing is a current, and EF is a solid.
So you ever watched Grey's Anatomy before?
Yeah, I used to watch it on channel 9 and channel 6. I think that
Oh, right. Sorry.
6. I never watched it in depth. I used to watch House more.
Oh, you should watch it in depth.
Okay.
It's really nice. I only reached season 2 though.
Okay.
Have like 19 seasons.
I find it don't make sense when there's so much seasons. Like, gosh, man.
I know, but like I like the show, so but it's not on Netflix. It's on Disney Plus. That's like the only thing.
I don't use Disney Plus or something.
Um,
I don't just watch it on them illegal streaming websites.
oh yeah.
All right, so everybody have this copy down.
Yeah.
All right. Right. And copy this song as well. Aliyah, let me read it first before we copy down. So Aliyah, read after me.
Observe the sections of the graph where there are no temperature changes. Heat is still being lost at these points but without temperature change. This type is heat. No, what? You mean this type of heat?
Yes, this type of heat.
This type of heat is known as
Later.
latent,
Later.
latent,
Yeah,
latent,
later. Latent.
latent heat is thermal energy being used to either reform intermolecular bonds or break them. This type of heat is lost or gained only during changes in state of matter,
Right. So
i.e.,
don't worry about that.
okay,
So let me explain something, right? Explain something. When you change in state, let me just say you're going from a liquid to a solid. What happened to the intermolecular bonds? You're going from a liquid to a solid.
wait, what was that?
What's happening to the intermolecular bonds if you're going from a solid to a liquid?
Um,
Where's the intermolecular bond stronger? In a liquid or a solid?
in a solid, so the intermolecular bonds, like, they, they,
Breaking.
yeah, they break in.
And that requires energy. And that is known as latent heat. So copy this on. Here, copy this song one time. You gotta copy this whole thing down. And then we do a question. And and this basically wraps it up for thermodynamics. Woohoo! Right? So copy that whole thing down. When I copy that whole thing down, we go into the questions. Right? So Justin, you there?
Yep.
So Justin, when you change in state, does that require energy?
When you're changing state,
Yeah. Like
Uh,
you're going from a solid to liquid, gas to liquid, that kind of thing.
yeah,
Yeah, remember what I said earlier? If you're
yeah,
changing, it takes energy to change. If you want to become ripped, if you want to become buff, and you have to change,
yeah,
and then as well energy to change.
yep.
Right. So anytime you're changing state requires energy. And that energy is used for what? What our energy is used to do?
Repeat back.
That energy is used to what? What is that energy used for? It's in
Chain.
it's in the sentence.
Oh,
Over here. This is over here.
observe the section on the graph where there's no temperature change. Heat is still being lost at these points, but without temperature change, this type of heat is known as latent heat.
Mm-hmm. Continue.
Latent latent heat is thermal energy being used to either reform intermolecular bonds or break them.
Wait,
This
wait,
type of heat is
wait there. I read back that part from it carefully.
either reform intermolecular bonds or break them.
Right. Let me just say going from a solid to a liquid. Which one has stronger intermolecular bonds? The solid or the liquid?
Solid
So if you're going from a solid to a liquid, what are you doing with the intermolecular bonds?
breaking them.
Right. And if you was going from a liquid to a solid, you would have to reform the intermolecular bonds, and that process requires energy.
Oh, okay.
So if you okay, here this, let me just say you get a pot belly. Let me just say you want to get a pot belly. You want to get fat. And that requires energy. I real how to eat food and things.
Yeah,
I don't know why I would become want to become fat, but yeah. And if you want to become buff and lean, that also requires energy. You have to hit the gym. You have to eat specific diets. So my point is, any change in state requires energy. In this, we call it the latent heat, right? You had this copy down, right? Did you copy
yep,
this?
yep.
Okay, cool. Um, copy all of this down. Nicholas in class. The internet probably won. Right. Aliyah, are you using any different colors or is still one color?
A highlighter.
All right. Fancy thing, fancy thing.
Kinda. It's not looking nice. My handwriting not neat today.
That's okay. Once you still contact once.
Yeah.
Check the website. What's good? No problem. Be all right. Yeah. 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 Right behind us. That's it. Yeah. Right, so you all have everything copied down? Oh, I can't rush it on it.
Yeah. Again, to do the table now.
Justin, let me know how things going. You still nervous about the match?
Mm, yeah, kinda.
Cool.
Gotta go and prepare after now.
Right. But you're copying on the table, right?
Yep.
Okay, cool. Alia, you want to hear a little secret?
Yeah,
Eh, When I was in secondary school, I didn't understand this thing for nothing.
really.
Yeah. My teacher barely explained it. So I didn't know. I just know I had to write back the same thing and just follow the example, but I didn't know. I didn't understand it at all. Yeah.
Hmm.
We understand, right?
Yeah.
You understand that it takes energy and discipline to change. Cool, cool.
Ah, wow.
Yeah.
You
It
make it sound like a bad student.
takes energy to get a 80 in that maths or 70.
Okay.
But you could do it. Even,
Yeah.
even if you get a 70 or high 60, I'll be happy.
I was in my 60s though, so it's only the coursework.
Oh, so funny. Ooh,
Yeah, I don't know what happened.
it makes you bad.
Mm-hmm. I don't know what I can do when I go back to school though. Ugh, I hate that lady so much. She's just discouraged me from my work.
Ooh, it's like that sometimes.
What was
Wait,
that?
I say it's like that sometimes. You have a teacher like that, but what you gonna do?
Yeah, but I just had to be the unlucky one.
Unfortunately,
Yeah, I don't know why.
right? Justin, what is the latest?
Yeah.
I really find it out of place how it's so quiet. I feeling then a bit sad. I hear it all that.
Uh, nah, I been studious.
That's good. That's good. Hey, one color or using some different colors?
Nah, just black.
Oh,
I had to buy some colored pens. Or borrow some.
Alia, buy him some color pens.
No, 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 I got. I got.
Way.
Okay, well, suffer with yourself with your black pen.
Like I say, you could have support Alia, buy some corn soup from Alia and them, and Alia buy a couple pen. MS Superstore right. That work out.
He playing stush.
Yeah, apparently.
Yeah.
Yeah, gents. Ever since he saw this crickets. Hey.
Mm. See, it's true. Look, he gone silent.
Yeah, he's like, he not talking to himself. Wait. Justin.
Yeah.
Yeah.
What?
What's it?
No.
Way, boy, way. Alia. Hey, that's crazy. That's crazy.
Um. uh, okay.
We will see how you're not talking and think how you kind of yeah, let's touch.
Yeah,
Me? We.
you do. You don't talk.
I just be studious with my work. Mm.
Mm.
But
Okay,
wait, if you was to there, see the answer just now, because you'll be paying attention to everything.
We.
exactly.
Exactly.
S- He lying. Something distracting him.
Right? How far did you all reach in copying this note down?
And the last section, the last part at the table,
Okay.
I
Justin,
need like 2 more minutes.
I on specific latent of vaporization.
all right. So as the name suggests, vaporization. That's when you go in from a what to a what. Vaporization, vapor. Tamalia,
A liquid to a gas.
right? And Justin, fusion, fusion. That's when you're going from a what to a what?
Fusion,
Yeah, fusion.
liquid to a solid without temperature change.
Yeah, vice versa. As the,
Nice. Mark.
as the name suggests, fusion. Like when you turn into a solid, you fusion. Yeah. And vaporization is gas because it's vapor.
Yeah.
They can remember it like that.
Okay, I don't.
Right. Nice. Justin, you let me know when you finish.
Yeah, I'll let you know when I finish.
So Alia, now that you know this extra piece of information, let me give you an example where we would use this formula. So we have E is equal to MLF, we have E is equal to MLB, right? Let me ask that question. Is there a temperature change during fusion and vaporization? Is there a temperature change?
No.
There is not. So you use this formula, you use those formulas when there's a change in state, and you use the other formula when there's a change in temperature. Just keep that in mind. That's how you differentiate the formulas. Because
Okay.
like I say, I didn't understand this thing at all when I was in secondary school. Hopefully, I don't get tired by that. Like I always used to be wondering why I using this formula, when to use this,
Hmm.
right? So, Alia, let me just say we have a pan, and in the pan you have some ice blocks, right? So you want to turn the ice to water at 50 degrees Celsius. So you want to turn the ice. What temperature is ice?
0 degrees Celsius.
Technically, ice could be anything below zero. But let me just say,
Yeah.
and you want to go from ice to a 0 degree Celsius to water at 50. Let me explain what have to happen. Before you could heat up the water and the ice had to melt first.
Yeah.
So the ice gonna turn to water at how much degrees Celsius?
Degrees Celsius.
How much? You say 50 just now?
Yeah.
Let me ask that question. When you melt ice, the ice is be hot? Or the ice, sorry, I'm not saying
No. No, it is it don't change. The temperature don't change.
it don't change. So when ice immediately melts, the temperature of the water is how much degrees? It don't change. So if ice was 0 degrees Celsius, what the water will be? Alia?
Hello.
Yeah, what temperature the water will be as immediately after it melts?
Um.
It will be 0 degrees Celsius.
Yeah, it wouldn't change. Sorry.
Be- Because heat is still being lost at these points, but without temperature change. Again, let me ask you a question. If if you heat up ice, the ice the ice will turn to water, and that water, will that water be immediately hot or will that water be immediately cold? If a block of ice melts, will the water be cold or the water be hot? Amalia.
If the ice melts. No, it'll be cool. It's
Right,
not hot.
the water from the ice go be real cool, and
Yeah.
and when it turns to water, and it's only then that water could get hot.
Mm-hmm.
Right, so ice will turn to water, and that water will turn to water at 50 degrees Celsius, you understand?
Yeah.
So the ice turn to water first, and it's only after it turns to water, then they could heat it up. Right, that is it. So for this portion over here, what formula would I use? Ice to water. What formula am I going to use? MLV or MLF? Or MC delta theta?
Um, that'll be
Are you using fusion or vaporization or MC delta theta?
it didn't have a temperature change.
They never temperature change, and it changed from,
Um, uh, solid to liquid.
right. So which formula does I get rid of one time? I have three formulas in this whole
Fusion. Fusion.
fusion. I get rid of fusion,
No, you get rid of vaporization
get rid of vaporization, and what else I get rid of?
and the E is equal to MC delta theta.
Right, because that one is when you have a change in temperature. So the only one that makes sense is fusion. So you would have to calculate fusion here. So the answer for this could be you got to use E is equal to MLF. And for this portion now, you're going from water at 0 to 50, you're going to use E is equal to MC delta theta. You understand?
Yeah.
Right. That's as hard as the questions get, more or less. So Justin, copy that down. Well, let me know where you reach.
I finished.
You finish, right?
Yeah.
Cool. So let me explain what I was explaining earlier. Let me just say it's a real hot day, right? It's a hot day. And you throw some ice on the ground.
Right.
What is the temperature of ice?
Ice. 0 degrees Celsius.
Right? Oh, because of the sun, the ice will turn to what?
Because of the ice, so it into liquid or water.
It will turn to water, right?
Right.
But our water, okay, let me just say outside, it is 5 degrees Celsius. When the ice melts to water, would the water be 35 degrees Celsius?
Mm, yep.
Think about it logically, right? You put ice on the ground, right? You put ice on the ground in the hot sun, right? You with me?
Yeah.
When the ice melts to water, will that water be 35 degrees Celsius or will it be cold?
Maybe 35.
You sure about that?
I think so.
Let me think about that, right? So you have a block of ice
Mm-hmm.
and the block melts.
Right.
When when the ice melts in, that water will be cold, it will be hot.
Cool.
Right? If you hold a block of ice in your hand, that water will be cold or hot.
Cool.
Right? So as the block of ice
Oh,
melting, as the block of ice is melting, it will turn to liquid, but that liquid it turn to, it will be hot or cold.
cool.
Right. So the water will be at what temperature? Right after it freezes, it will be at what temperature?
Really about that.
So as soon as that water melts, what temperature would the water be?
50. No, 0.
It'll be 0. Because I'm
Yeah.
actually, you know, think about it. Imagine holding a block of ice in the sun, right? Right?
Right.
When the ice melts, if the ice when the ice melting, right, and the water on that is be cold,
Mm-hmm.
and it will take a long time for it to reach 35 degrees Celsius, which is hot.
Yeah.
Yeah. So when ice melts in the sun, it is turned to water at 0 degrees Celsius. And it will take some time after. So after it's water now, imagine you have a puddle, right? The ice just melt and the puddle is so cold.
Yeah.
After some time, the water will reach 35 degrees Celsius. You understand?
Yeah.
So this process over here, was there a change in temperature?
Mm, yeah.
No. I'm going from a water what?
Solid liquid.
I'm going from a solid to a liquid. So there's a change in, there's a change in what? Understand? Ice,
Yeah.
so what is ice? Ice is a what?
Oh, solid.
A
Solid to
liquid.
liquid.
Right, solid to liquid. So that is fusion vaporization or E is equal to mc delta theta. What formula using for that?
E equals to MC delta theta. Oh wait,
Oh,
no. Wait. Fusion? Because temperature changing.
right. Wait. Aware,
Uh,
remind me the guidelines for E is equal to mc delta theta.
the steps for MC delta theta, the change in temperature, not to stay in state.
Wait,
Theta does not huh?
that's the main one there. Read it back for me one more time.
Change in temperature, not in state.
Right. So to use this formula, there must be a change in temperature, not in state. So if you have a change in state, you're staying far away from this formula, right? Very far. Was there a change in temperature over here?
Nope.
No. So that's one reason not to use it. Second reason, is there a change in state?
Yeah, no. Wait, yes.
Describe the change in state.
Solid to liquid.
Solid to liquid. Right. So that is fusion. You understand?
Yeah.
So for this change over here, I would use the formula E is equal to
Ah, hold on. E equals to MLF.
and
Right,
for this portion over here now. So after the ice turns to water, and keep up here, sir, the ice will melt, right? But when the ice melts, that will be cold water. It'll be cold water, right?
right,
So this is cold water on the ground,
right.
and the sun is 35 degrees Celsius. And and eventually the sun will heat up the water at 0 degrees Celsius to 35.
Yeah.
Right. What formula we will use there? E is equal to what?
The vaporization formula, which is E equals to MLB.
Nah, think.
Huh?
I want you to
Oh
look,
wait, no. The E equals to MC delta theta
explain why we're using that one here.
because the change in temperature.
Right. Am I changing state?
No,
No. Going from water to water, right?
right.
So I want you all to copy down a small example. It's an important example. Right? And wait, before I copy down the diagram, this is the heading I want to let put. Right? This is the heading. Ice. Wait, Okay, to put here. Ice melting in the sun. Right? So I want that's the heading. Ice melting in the sun. Right? So the sun rays, it hits in the ice cube, it hits in the water, and eventually the water will turn to 35 degrees Celsius. Bingo. Right? So you'll copy the song. Hey, Nephron, partying boy. Right, so you all have the diagram copied out. Guys, Ali and Justin.
Yeah, yeah,
Okay,
now finished.
Justin.
Yeah.
So Justin, you really had to think more, eh? I don't mean it in a bad way, but you really had to think more consciously, right? You had to think a little more. You can't fall for anybody tricks,
Yeah.
right? So we basically finished with thermodynamics. Next class, we're gonna do questions. Yeah, questions for it next class. The only thing we could probably do again is the experiments, but that's hardly come. Yeah. I could probably give all that up for homework, or like a copy down that. So I'll send the notes already. Let me just later six.
We have physics Monday.
I'm gonna check that schedule. Is it in the schedule?
It's supposed. I think so.
We'll check it. Yep. Monday and Tuesday. Right? But that's it for thermodynamics. And Wednesday, maths started and add maths. Ooh, I find time flying real fast.
Yeah.
Scary. I don't like it. Ooh,
Oh God, yeah, me neither.
are gonna be in school again just now?
Oh, don't remind me.
Oh. But anyways, guys, I hope you enjoy your day. Justin, best of luck with the cricket match.
Yeah, yeah, I'll see and send you some videos and tell you about it.
Nice. And well, Aliyah, I don't know if I might check Aliyah this evening.
Okay.
See. All right, but you take care. Enjoy the rest of your day.
You too.
Bye.
Bye.